Okay, we looked at emissions from agricultural land and forests. Let's look at ways to reduce emissions by managing agricultural lands. We saw this in another chapter before. I'll show it again because we can hardly ever look at this too many times. Basically, it's showing global greenhouse gas emissions by sector, and this is from 2020, but I think the data is from 2019 probably, or older. Nonetheless, energy industry occupies a huge chunk of this pie chart in terms of sectors. So energy use in the industries is over 24%, transport is about 16, and energy use in buildings is about 17 out of this emission here. And agriculture occupies about 18.4%, but as we said before, the total emission from the food industry is at about 25%. We will look at livestock and manure. We'll look at agricultural soils. We'll talk about rice cultivation, crop burning, and deforestation for agricultural land conversion is a huge problem, and cropland fallows and abandoning and so on also contribute to the emissions. Okay, what are the management options? Obviously, nitrogen fertilizer is a big contributor to emissions. The Haber-Bosch process of producing ammonium at industrial scale is considered as the biggest most important innovation discovery for food revolution and population growth, but some people say it was also used to make bombs, so it killed more people than it saved. But nonetheless, the nitrogen fertilizer use is now a massive perturbation, not only to the carbon cycle but also to the nitrogen cycle, which has to be watched out, which we don't talk about much, but actually it's a massive perturbation, which is not a good thing. So here we are looking at fertilizer consumptions in million tons nitrogen and meat consumption in kilograms per capita. They tend to be related because the feed for meat production tends to be associated with meat consumption as well. So different regions are shown in terms of fertilizer consumption. I'm going to ignore meat and cereal here and just focus on the fertilizer consumption. So you can see that Asia, which has had massive population boom and dealt with its food security issues by going to the so-called green revolution in places like India, have relied heavily on nitrogen fertilizer. South America down here, North America, Oceania, which are the countries on the maritime continent and so on, and the meat consumption is up here, which has also obviously grown quite a bit, and we talked about how reducing meat consumption can greatly reduce methane emissions, for example. Okay, so there are many ways to reduce agricultural emissions. This is just one kind of a schematic which talks about integrated cropping livestock system example of managing. There are also now smart agriculture, CSA generally it's referred to as climate smart agriculture, which proposes to use Internet of Things and other ways to do precise irrigation, precise manure applications, fertilizer applications, precise harvesting, tillage, etc., etc. But in this case, integrated cropping livestock system basically looks at livestock graze the field, crops, pastures, either directly or after harvesting. So this is a way of managing livestock that it helps farmers collect the manure and apply it to fields as fertilizer, in addition to a small amount of synthetic fertilizer. So these nitrogen fertilizers are the so-called synthetic fertilizers. Manures are argued to have less emission, also better impact on soils by creating more spaces, more pore spaces for water to penetrate, more binding of minerals important for plants, etc., with soil to create better plant growth and even micronutrient uptakes and so on. This natural fertilizer improves soil health and soil quality, thereby increasing crop yields while reducing greenhouse gas emissions as less synthetic fertilizer is required. Okay, so this is a kind of a loop. It seems to work. The question is always how scalable they are. Do they work well with fractionated lands like in India, where everybody owns 1 or 2 acres? Or does it work better for industrial farming like in the US or Europe, where people own hundreds of acres? Okay. The story of nitrogen fertilizer, obviously, there are additional ways to lower greenhouse gas emissions associated with fertilizer use, which include use low carbon or no carbon fuels in fertilizer manufacturing, so reduce emissions in the life cycle itself. Capture biosolids and waste waters and convert them to nitrogen amendments. Fertilizer is something that supplies nutrients directly to the plants through the soil, of course, but amendment is where you are modulating the soil properties to indirectly favor crop yields, crop growth, healthy soils, quality and quantity. Okay. This also helps remove nitrogen pollution from wasteways. Nitrogen pollution, especially in coastal waters, is a tremendous problem now, so that's very important. Use organic nitrogen and slow release fertilizer so that it doesn't get wasted and get washed away, especially with heavy irrigation. If the fertilizer is released slowly, it can result in lower emissions and have a lower overall carbon footprint. Use buried or drip irrigation. Incredible innovation, but there are caveats because it is found in some parts of India, for example, that drip irrigation tends to increase the area of being irrigated, so the overall water use doesn't actually reduce. So some monitoring of the total water use is also needed, maybe a command-based policy over there. Supply only the amount of water the plant needs, can minimize overwatering that can stimulate nitrous oxide emissions and increase salt content of the soils. Okay. So precise irrigation under climate smart agriculture also proposes to do that. Use nitrogen fixing cover crops. Nitrogen fixing plants or species that can pull nitrogen from the atmosphere and supply to soils. So nitrogen is an important nutrient. Nitrogen fixing plants in the legume family or the pea family are often used as cover crops during fallow periods. So you may have only one sowing season and leave the ground fallow, which tends to lead to soil erosion as well as organic carbon loss and increased emissions, which can be reduced by nitrogen fixing legumes. Nitrogen fixing cover crops can also stimulate nitrous oxide emissions, but they do not result in the energy costs associated with inorganic nitrogen fertilizer production. So nitrogen fixing is kind of organic fertilization, natural fertilization, which doesn't require the energy used in producing nitrogen fertilizers. Okay, so that's kind of the few ways in which agriculture can be managed to reduce emissions from agriculture, which we said is 18% or 25% based on whether you look at the whole life cycle or part of just the agricultural part of it.